All right, so today we're going to be talking about symmetry in regards to figures on a coordinate plane and figures in general. So I had asked you to watch a couple short videos from Khan Academy yesterday that give you a little intro into symmetry and that talk about line symmetry and point symmetry and rotational symmetry. And I will still have them on this module today for you to watch. And they're really just, a supplement for you to get another explanation of symmetry. Sometimes symmetry can just take a little while to really understand the concept and what we're talking about, just because it depends on how your brain works. So for some of you, it might click right away and you get it. And for some of you, it might take a little bit longer to really understand specifically point symmetry and rotational symmetry. So this is a little summary here of the types of symmetry, some examples, and then we're just going to go over some different figures, and then you'll practice with identifying types of symmetry as well. So there's nothing for you to write down. I have a copy of these notes on Canvas for you to go back and refer to. So you'll have it, but you don't need to write anything down unless you would like to. This is really just for you to learn about this topic. So the first type of symmetry is line symmetry. So this is probably the one that makes the most sense to you. You have probably seen this symmetry before and are more familiar with it. So line symmetry, really just think of folding a piece of paper in half. So if you have a figure and then you fold it in half, is it mapped onto itself? So basically, is it a perfect match? So in geometry, we say, can the figure be mapped onto itself? So what that means is mapped onto itself, a perfect match. So if you imagine yourself folding this triangle in half, it would be a perfect match. So it would map onto itself, and that means it has a line of symmetry right here. So it has that symmetry. Think of a mirror image, think of a reflection. This is line symmetry. So this is something you're probably more familiar with. The two next types are something that you're probably less familiar with. So that's point symmetry and rotational symmetry. So both of these types of symmetries involve rotating a figure around a center point. But the difference is really the degree in which we rotate these figures. So for point symmetry, we are specifically talking about a 180-degree rotation. Okay, 180 degrees. So we say a figure has point symmetry if the figure is mapped onto itself by rotating the figure 180 degrees about a center point. And when we're saying mapped onto itself, we're saying that it's the same. It's the same figure after this rotation, so it looks no different. It's a perfect match. It maps right onto itself. So what I want you to think of is upside down. So is this figure the same upside down? So if I rotated this end so that it was upside down, it would look the same. So it has point symmetry. Okay, so point symmetry is when we're talking about a 180-degree rotation. Rotational symmetry, okay, is when we're talking about a rotation anything less than 360. So yes, that does include point symmetry. That includes a 180-degree rotation. So if something has point symmetry, then it automatically also has rotational symmetry. However, the converse is not true. So if it has rotational symmetry, that does not necessarily mean that it has point symmetry. So for example, this N, it has point symmetry. However, if I rotate it, say 90 degrees, it's not going to be the same. Whereas if I look at this, picture of a sun, think of like a pinwheel or anything that's kind of this perfect circular type of shape. If I rotate this, say 90 degrees, it's going to look the same. If I rotate it upside down 180 degrees, it will still look the same. So it has point symmetry and it has rotational symmetry. So it has both. Okay, so that might be a little bit confusing. I understand that. We're going to look a little bit more and hopefully eventually it'll start to make more sense, kind of the difference between point symmetry and rotational symmetry. So your job is basically going to be to identify these figures and if they have line, point, rotational, or no symmetry. Okay, so here are some examples that we're going to look at, and I'm going to show you some rotations off to the side here so you can see a little bit better. So if we look at this hexagon here, so this has line symmetry, point symmetry, and rotational symmetry. So let's look at why. So line symmetry means I can draw a line down the center. I can fold this in half and it's going to map onto itself. It's going to be a perfect match. If you imagine folding this in half, I could fold it in half this way vertically, or I could fold it in half horizontally, and it is going to map onto itself. Okay, so that's kind of easy to tell. Point symmetry. I'm going to come over here to my figures. Okay, so here is a similar hexagon. If I rotate this, so point symmetry is saying if I flip this upside down, okay, so if I rotate it so that it's upside down, is it the same? And the answer is yes. So it's the same. It looks the exact same. It is mapped onto itself. So it has point symmetry. And because it has point symmetry, it automatically has rotational symmetry. So I can rotate this any less than 360 and it will turn out the same. So this is a 180-degree rotation. And then 360 we know is putting it all the way back to the beginning. So this has all three: line, point, and rotational. So let's take a look at this triangle here. So this triangle, much like the triangle above, I could fold it in half and it would be a perfect match. So it would map onto itself. So then I want to check point symmetry. So when you are checking point symmetry, you're thinking, would this be the same if I rotate it so that it's upside down? So here's my triangle. I'm going to rotate it 180 degrees. So we'll say that's about 90 degrees. And that's about 180. So is it the same? No, it's upside down. Okay, and it's not the same. So this point is down here, whereas before it was up here. It's moved. So this does not have point symmetry. Okay, however, it might still have rotational symmetry. So I'm going to create just another one here. And let's take it back to the original. Okay, so here's the original. Here's the copy. So if I rotate this 180 degrees, it's upside down, it's different. But if I rotate it another, say, 90 degrees or so, if I rotate it, looks like about 270. Notice how it is the same figure. So I haven't rotated it a full 360, and I have a figure that's the same. So this has rotational symmetry. So I was able to rotate it a degree that was less than 360 and make it the same figure. So it would map onto itself. So map onto itself means, look, it's identical. It matches right up on there. Okay. And it was less than 360. So that's why it has rotational symmetry, but it does not have point symmetry. So if I remind you, this is 180, checking for point symmetry. So this is putting it upside down. Not the same. Okay, it's not the same. But if I go a little bit more, it ends up the same. Okay, so that's rotational and point symmetry. So that can be a little bit confusing. Okay, so let's look at some more. Okay, so we have a parallelogram here. So if I imagine a line down the center and folding it in half, it is not going to map onto itself. So it does not have line symmetry. Does it have point symmetry and rotational? It does. So let's check that out over here. So I have this parallelogram that looks pretty similar. Let me make it a little bit more like that one. So let's rotate this. I'm going to rotate this upside down, and I'm going to see if it looks the same. So I'm actually going to make a copy of it so we can see. So I'm going to rotate this. This is about a 90-degree rotation and 180. And look at that. So upside down, you can see it right there too. And it's mapped onto itself. So it is the same. So it has point symmetry. Because it has point symmetry, it automatically also has rotational symmetry. Okay, so if it's point, it's automatically rotational, but not the opposite. So not the converse. If it's rotational, that doesn't necessarily mean it has point symmetry. All right, let's look at a right triangle here. So this has no symmetry. So I have a right triangle right here. And I'm going to see. So if I cut it in half, like say there was a line right here, it's not going to be a match, right? If I fold this in half, this would be over there. It would not be a perfect match. So it does not have line symmetry, and you can kind of you just have to visualize it, okay? So it's a little bit of abstract thinking. For some of us, this will click right away, and some of us, it's just going to be like, okay, I'm confused. It's hard to think about. That's okay. We all think different ways. Just keep thinking about it and keep kind of just testing things out. So imagine yourself folding this triangle in half. Would it be a perfect match? No, in this case, it wouldn't. So this one does not have line symmetry. So let's check my rotations here. So if I rotate this and make it upside down, so 90, 180. So it's not the same triangle, okay? It's facing the opposite direction. It does not map onto itself. So let me make a copy of this and show you exactly. Okay, so here's the original. I'm going to rotate it so that it's upside down, 180, and you can see it does not map onto itself, so it's not a perfect match. Okay, and if I keep trying, so let me check for rotational symmetry. Let me see if I can rotate it like, okay, a little bit more, no, not a match, not a match, only until I get back to 360 is it a match. So that does not have rotational symmetry. Okay, it has to be something less than 360, so not making that full rotation back to the original. So this specific one has nothing, it's none. Okay, so a right triangle has no symmetry whatsoever. Let's take a look at a few more. Let's look at this star here. And I'm going to have this document on Canvas for you as well. So you can honestly, if you have PowerPoint and you want to play around with this rotation, play around with it. That's how you're going to kind of figure it out. So here I have this star. So you can probably tell if I fold this star in half right down the center, it's going to be a perfect match. So it will map onto itself. So it does have line symmetry. So let's flip it upside down or turn it upside down and see if it's a match. So I'm actually going to make a copy of this. All right, so I'm going to flip it upside down, turn. Okay, so it's upside down right now. So here's that top point, and now it's down here. So it's like, okay, maybe, no. Okay, notice it does not, it makes a pretty little figure here, but it is not mapped onto itself, so it does not have point symmetry. So let's see if it has any sort of rotational symmetry. So let me just turn it a little bit more and see. So remember, this is the top point that I'm dragging right here. So if I turn it and boom, it looks like it maps right onto itself. And I could keep turning it. There's that top point, and it does kind of map onto itself. So this actually does have rotational symmetry. So this kind of star figure has rotational symmetry. So I would do line and rotational. So notice it has rotational, but not point. All right, and you can see the others here, and I'm going to pause for a moment. So I want you to just go ahead and take a look at these figures. Try rotating them a little bit and see if you can understand what kind of symmetry these have. So do they have point symmetry, rotational symmetry, all of that? Give it a try. Just take a little break and play around with it yourself so you can get a good grasp on this concept. And then I will just go over them again and explain them a little bit. All right, so hopefully you tried rotating these and kind of saw what kind of symmetry they had. So let's take a look. So we have this kind of little figure here. So this has point symmetry, which means it automatically has rotational symmetry, and it does not have line symmetry. So if I kind of try to fold this in half, there's really no way for it to be a perfect match to map onto itself. So I'm going to turn it upside down to confirm. I'm going to go ahead and make a copy of this. And let's rotate it and see if it's the same. So I'm going to rotate it 180. and 80 degrees, and it's the exact same image. So it maps onto itself. It's a perfect match. So it has point symmetry, which means it automatically has rotational symmetry. Let's take a look at the A. A lot of times our letters don't have as much symmetry. So an A, let's see. If I cut the A in half, will it map onto itself? Will it be a perfect match? Yes. So if you imagine having the letter A and folding it in half, yep, it would be a perfect match. So let's try to rotate this and see what happens. So I'm going to rotate it 180 degrees. 180. Is it a perfect match? No, it's not. If I keep going, is it ever going to be a perfect match? No, not until I get back to 360. So that does not have point symmetry and it does not have rotational symmetry. Let's take a look at the lightning bolt here. All right, so our lightning bolt. Can I fold this in half anyway, make it a match? No, I can't. So let's try rotating it and seeing what happens. So I'm going to rotate. Okay, so it's upside down. No, doesn't work. And really no sort of symmetry whatsoever. So that one has none. All right. And that's all of the examples. So what you're going to do is try to look at some on your own, and that is on Microsoft Forms, and you're going to try to figure out if they have line, point, rotational symmetry. And that will be it.